When we look at Earth from space, we see a blue and green planet alive with forests, oceans, and drifting white clouds. But if we could rewind time to the planet's earliest days, we might encounter a very different face of Earth. Perhaps, in the beginning, Earth wasn't blue or green at all but glowing in shades of violet. This fascinating idea, known as the Purple Earth hypothesis, invites us on a journey through science and imagination. A journey into the world of purple microbes, primitive pigments, and the light that shaped life. Could it be that the original color of life was purple? And if so, what changed Earth into the vibrant planet we know today? In this video, we travel back to Earth's ancient past where biology, philosophy, and wonder converge to reveal a new portrait of our world. Scientists believe that in its earliest formative stages, Earth may not have appeared blue and green as it does today, but rather bathed in a purple hue. If we look at Earth from space today, our planet appears as a blue sphere with thin white clouds and landmasses in shades of green and brown. But in its early days, Earth might have been colored in purples and violets instead. This idea is known as the Purple Earth hypothesis, first proposed by Professor Shilodicea das Samo, a molecular biologist at the University of Maryland, and Dr. Edward Squierman, an astrobiologist at the University of California, Riverside. According to the Purple Earth hypothesis, early photosynthetic life on Earth may not have been green but purple. If so, Earth's oceans at the time were likely filled with tiny purple microbes that gave the planet a soft violet tint. Most modern photosynthetic organisms from trees to marine bacteria are green due to a pigment called chlorophyll. Chlorophyll absorbs nearly all visible light wavelengths except green, which it reflects, making plants appear green to our eyes. However, it's curious that green light is one of the most energetic parts of sunlight, with a wavelength around 500 nanometers, yet plants don't use it. Why did evolution take this path? The answer may lie in the era before oxygen existed in Earth's atmosphere. Back then, the atmosphere was rich in carbon dioxide and methane, and most life thrived in the oceans. According to the Purple Earth hypothesis, many microbes of that time used a simpler pigment called retinal instead of chlorophyll. Unlike chlorophyll, retinal absorbs green light and reflects purple. Some microbes still use this molecule today, such as halobacteria, which live in salty, low-oxygen environments and have purple membranes. As reported by IFL Science, retinal is chemically simpler than chlorophyll and may have been one of the earliest light-absorbing molecules in Earth's history. At that time, oxygen levels were low, but for retinal-using organisms, this wasn't a problem. If Earth's early oceans were full of such microbes, the entire planet may have appeared violet from space. Over time, evolution found new ways to harness sunlight. Since retinal-based microbes absorbed most of the green light, newly emerging organisms that relied on photosynthesis had to use other wavelengths, namely blue and red. Thus, chlorophyll evolved. Chlorophyll absorbs blue and red light to produce energy and reflects green light. As a result, green life began to spread. Around 2.4 billion years ago, in an event known as the Great Oxygenation Event, chlorophyll-containing cyanobacteria dominated Earth. These green microbes released oxygen during photosynthesis, transforming the atmosphere and paving the way for more complex life. From that point on, the purple Earth gave way to the green and blue planet we know today. Today, retinal-based photosynthesis no longer plays a major role on Earth, but it may still exist on other planets. When astronomers search for signs of life on distant worlds, they often look for green light signatures that indicate chlorophyll, since nearly all life on Earth depends on it. However, the Purple Earth hypothesis reminds us that life isn't always green. Under different conditions, it could be purple, orange, red, or even colors invisible to the human eye. Perhaps on other planets, life isn't based on light or photosynthesis at all, but on entirely different processes. So in the search for life across the universe, we shouldn't only look for green because life can appear in any color or form. Despite many uncertainties about the formation of Earth and other planets in the solar system, 3 dominant models have been proposed: core accretion, disk instability, and pebble accretion. The core accretion model mostly applies to rocky planets, while disk instability is more relevant to gas giants. However, the third model, pebble accretion, has helped resolve many issues in the first 2, including the speed of material accumulation. None of these models are definitive yet, and researchers continue to investigate them.